So, if you've been keeping track of artificial intelligence lately, say the last couple of years, you've probably been wrapped up in chatbots, right?
Nope.
And large language models, figuring out that perfect, really intricate prompt to get exactly what you want out of it.
Yeah, we've all sort of become prompt engineers, haven't we? Focusing on that active engagement.
Exactly. Telling the AI precisely what to do, step by step.
And look, that active model, whether you're using ChatGPT or, something like DeepSeek, it's incredibly powerful, no doubt about it. But at its core, it still demands quite a bit from the user. There's cognitive friction there.
Friction. How do you mean?
Well, it forces you to stop what you're actually doing, your main task, switch context, engage manually, type out these explicit instructions.
Right. Even if the results are amazing, the process itself is still work, user work.
Exactly. Significant user work.
But our sources, they're pointing towards a different kind of AI revolution happening right now, maybe a deeper one. It seems to be fundamentally changing how tech works around us.
It is. It's much quieter, much more pervasive. It's the kind of revolution you might already be living inside and, frankly, not even realizing it.
Okay, so we're talking about AI that hides in plain sight.
Precisely. We're talking about ambient AI.
Ambient AI, or sometimes called Ambient Invisible Intelligence.
That's the more formal term, yes. Ambient Invisible Intelligence, or AII, sometimes pervasive AI. The names all point to the same idea.
Mm-hmm.
Technology that's built specifically to, well, paradoxically, take a back seat.
So its main job is not to be noticed.
Pretty much. Its function isn't to flash a console at you or wait for your command. Its real goal is to operate seamlessly, continuously in the background. It's sensing, learning, adapting, all to improve efficiency and your experience, ideally without you lifting a finger or even thinking about it.
Wow, technology actively trying to disappear. That feels like a really profound shift in how we think about architecture, about design.
It is a fundamental architectural shift. And, Gartner clearly saw this coming.
Right. They named Ambient Invisible Intelligence a top tech trend for 2025.
They did. And they specifically called it a major move from technology being in between, something you interact with directly, to being in the background, just part of the environment.
It really feels like the next wave of automation, where the infrastructure itself starts to become intelligent.
That's a great way to put it.
Okay, so let's really unpack this then. Our mission for this deep dive is to get a solid understanding of this invisible engine. We need to figure out where it's already working, because it seems like it's in more places than we think, from logistics to healthcare, potentially life-saving stuff. And we need to talk about that foundational architectural shift it demands. What are the tech stacks making this context awareness possible? How is it being used in big, complex enterprises?
And, crucially, the ethical side. The strategic questions. What happens with systems that are, by design, always on and ever collecting?
Absolutely. Let's dive in.
Okay, let's start with the absolute core definition.
Right.
Because this seems to be where the paradigm really shifts away from the generative AI we're all used to. We've said ambient AI is tech you don't realize you're using, but how is it operationally different from just, I don't know, a really complex piece of software running somewhere?
Yeah, good question. The difference really boils down to two things: context and agency.
Context and agency.
So, like we said, active AI, your LLM, it needs manual engagement. You give it a prompt, it reacts, it's reactive.
Right.
Ambient AI aims to be proactive, and it's deeply context aware.
Proactive, meaning it acts on its own.
Essentially, yes. It has agency. It doesn't just sit there waiting to be told what to do. It performs tasks based on the complex real-time context of what's happening around it. Its environment, user behavior, sensor data.
So it's making decisions autonomously based on patterns it's learned and what's going on right now.
Exactly. It's running autonomously. Okay, that distinction, agency versus command, that feels critical. But honestly, the idea of AI having agency, that immediately brings up questions, right? Liability, audit trails. If this proactive system makes a mistake in, say, logistics, and it's costly, who's responsible?
That's a huge point, and it's definitely part of the necessary friction we need to discuss later. There are real challenges there.
Yeah.
But just looking at the structure, the design point is that ambient AI is constantly evaluating possibilities, like running a decision tree, using all these different data streams, always looking for the optimal state or the most helpful action.
And you argue this design is necessary. Why?
Because it's designed to solve that growing problem we talked about, cognitive friction.
Right, the cognitive friction point.
Okay.
I think that's really key because, once the initial wow factor of generative AI wears off a bit, you hit that frustration point. You realize, okay, now I have to stop what I'm doing, open another window, think really hard about this prompt, wait for the output, copy it, paste it back. It breaks your flow.
Precisely. The pain point becomes exactly what you said. I just want to use the AI without stopping my main workflow, without writing some complicated prompt.
Yeah.
And ambient AI is the logical next step to solve that. It reduces the cognitive load of all those small, everyday decisions or tasks. The user's role shifts. You're not managing the tool anymore. You're just experiencing the better outcome.
And we can actually see this invisibility already at work, right? In some pretty relatable, maybe low-stakes examples first. The kind that give you that aha moment about what ambient really means.
Definitely. The Bosch Series 8 washing machine example from the sources is a perfect, really subtle illustration.
How so? I mean, it's a washing machine.
Right, but think about how you don't use it. You don't manually weigh the clothes. You probably don't meticulously select the fabric type. You don't guess how much detergent is needed.
True. I just throw stuff in, add soap, press start.
Exactly.
Yeah.
But inside, it's using sensors, weight sensors, water turbidity sensors, and an embedded AI chip. It automatically calculates the precise detergent levels needed, the right water temperature, the optimal cycle time based on the load size and how dirty the water gets.
Huh. So the AI is just there, running quietly.
It's there running in the background, making dozens of these little optimized micro decisions. And the result, less effort for you, better wash, maybe saves water and energy.
Yeah.
But you didn't instruct it on any of that. That's the simplest form of ambient invisible intelligence.
That is subtle. Okay, now let's scale that up. What about a high-stakes scenario where context and proactive updates could reduce real human stress? The hospital example seemed powerful.
Yeah, think about being in a hospital waiting room. A family member is in surgery or recovery. You're stressed, you're anxious. You constantly want updates.
But you don't want to keep bothering the nurses who are clearly busy.
Exactly. So an ambient system can bridge that gap. It synthesizes data from multiple, often totally separate, hospital systems, the EHR, the operating room schedule, the bed management software, maybe even staff location data.
So it pulls all that together.
And it recognizes the context. It knows this family is waiting for news about room 412. So when the system detects the room cleaning is complete or the doctor has signed off on the post-op notes, it proactively pushes an automated, personalized update to the family's phone or a waiting room display.
Like, room 412 will be ready in 5 minutes, or your doctor is reviewing results now, expects to speak with you in about 15 minutes.
Precisely. And the key is no human had to stop their work to manually type and send that specific message. The system detected the status change, understood the context of the waiting family, and anticipated their need for information.
That's really context-aware intelligence in action, delivering high-value information right when it's needed most, without anyone asking.
Reducing stress, improving experience, and freeing up staff time. That's the promise.
Okay, so to make environments that can genuinely anticipate our needs like that, the tech required must be incredibly complex. It's clearly not just about having a powerful algorithm on a server somewhere. It sounds like creating an entire intelligent infrastructure.
It really is a foundational shift. Ambient intelligence fundamentally relies on this tight synergy, this marriage between AI and the Internet of Things, or IoT.
Creating what the sources call smart spaces.
Exactly. And it's important to stress this goes way beyond just connecting devices, which was kind of the first phase, sometimes called AIoT.
Right. Connecting things is one step.
This is about creating whole environments, homes, offices, factories, cities that can learn and dynamically adapt to the people and the processes happening within them.
And the market seems to be betting big on this. The numbers suggest serious growth. $18 billion market in 2022, projected to grow 24% annually through 2030. That's aggressive.
It's a very steep trajectory.
Yeah.
And it shows that this isn't just a niche concept anymore. It's rapidly becoming foundational infrastructure.
What's driving that investment? Is it enterprise adoption?
Absolutely. That growth is directly tied to businesses recognizing the need. There was a global IoT survey mentioned in the sources, found that nearly half, 48% of companies prioritize AI and machine learning for their future IoT deployments.
So they get it. Just connecting sensors isn't enough.
Right. Connecting sensors generates floods of data. That data is useless, maybe even overwhelming, without the intelligence layer to interpret it, find patterns, and actually act on the insights those sensors provide. That's where AMI comes in.
Okay, let's peel back the layers then. Let's look at the underlying architecture. Our sources talk about 4 key enabling pillars for ambient invisible intelligence. Can you walk us through those?
Sure. So first up, we have embedded AI systems.
Embedded AI, meaning the AI is right there in the device.
Exactly. Intelligence integrated directly into the hardware itself. We're talking custom chips, microprocessors, tiny, highly specialized machine learning models that are built right into the sensors, the smart speakers, the thermostats, the wearables.
So they can do some processing locally, even if the network is down.
That's often the goal, yes. The processing has to be optimized for very constrained environments, low power, limited memory. It's AI living on the hardware.
Okay, pillar one. Embedded AI. What's number two?
Number two is context-aware computing. This is really the core brain of the operation, the cognitive ability.
This is what lets it understand what's happening.
Precisely. It's the engine that leverages all that real-time contextual data we talked about, location, time of day, user behavior patterns, historical data, ambient noise levels, temperature, who is in the room. All of it.
To do what, exactly?
To optimize the experience dynamically. Think about adaptive lighting in an office. A simple system adjusts based on time of day. A context-aware system might adjust based on time, yes, but also on how many people are in the room, whether the projector is on suggesting a presentation is happening, maybe even integrating with calendars to know a focused work session is scheduled. It uses multiple inputs to tailor the output.
Got it. Much richer than just simple rules. Okay, then we need to process all this data. Which brings us to the speed issue, right? Especially for things like autonomous cars or emergency systems.
Absolutely. You can't wait for data to travel to a central cloud and back if you need millisecond reaction times. That brings us to the third pillar, which is architecturally very important: edge AI and fog computing.
Okay, edge and fog. We hear these terms a lot, but sometimes they get used interchangeably. Can you clarify the difference for us?
Yeah, good point. They are distinct. Edge AI means the processing happens right there on the device itself at the very edge of the network.
Like the smart camera example, analyzing video locally.
Exactly. The camera analyzes the video feed using its onboard AI chip to detect a specific event, maybe an intruder, and then it sends a small alert or a snippet of video rather than streaming raw footage constantly. The big challenge at the edge is model optimization, making powerful AI models small and efficient enough to run on that device's limited hardware.
Okay, so edge is on the device. What about fog?
Fog computing is a layer between the edge devices and the central cloud. Think of it like a local gateway or a mini data center, maybe a server rack in a smart factory basement, or processing capability built into a local 5G cell tower.
So it gathers data from nearby edge devices.
Right. It aggregates data from multiple edge devices in a local area and performs intermediate processing and analysis before sending summarized or more critical data up to the main cloud. It acts like a fog layer closer to the ground.
Okay, so edge for immediate on-device reaction, fog for local coordination and pre-processing, cloud for the big picture analysis and model training.
That's the typical hierarchy, yes.
Yeah.
This hybrid approach is really critical for building low latency, resilient, and scalable ambient systems.
Makes sense. Okay, and the fourth pillar. This one sounds a bit more futuristic.
It is definitely looking further up, but it's a key part of the vision. Neural interfaces and brain-computer interaction, or BCI.
Whoa. Controlling things with your mind.
That's the ultimate goal, yes. The ultimate form of seamless, invisible control. We're still in the early stages, of course. Think about companies exploring therapeutic uses first, like controlling prosthetics.
Like Neuralink and others.
Right. But the long-term vision in the context of AMA is to bridge human cognition directly with AI systems, decoding brain signals to allow for seamless intent-based control of your smart environment without needing voice, touch, or gestures.
That's a lot to think about. So putting it all together, the essential tech stack isn't just one thing. It's this deeply integrated ecosystem.
It has to be. You need the IoT devices gathering the real-world data, environmental, behavioral, acoustic, visual. You need edge and fog computing for that responsive, low-latency processing right where it's needed.
You need highly optimized AI algorithms running on that hardware to sift through massive data streams, find the patterns, anticipate actions.
And you still need robust cloud infrastructure in the background for the heavy lifting, scalable processing, training more complex models, long-term storage of user profiles, system-wide analytics.
It all has to work together, silently, communicating constantly, just to make the environment feel smart.
That's the goal. Effortless interaction built on complex, invisible infrastructure.
Okay, now that we've got a handle on the complex tech making this possible, let's focus on where this invisibility is actually creating the most immediate, maybe the most quantifiable value. Section 3 in our outline dives into applications. And the place where this seems arguably most mature right now, the most developed use case, is healthcare. particularly the administrative side.
Absolutely. The adoption of ambient AI scribe technology in clinical settings has been really quite staggering in the last few years. It directly addresses a massive pain point.
The documentation burden on doctors.
Exactly. So picture this. A doctor is having a consultation with a patient. The ambient AI scribe system is running in the background, maybe via microphones in the room or a dedicated device.
It's listening.
Just listening. But it's using advanced natural language processing. It can distinguish between the doctor's voice and the patient's voice, filter out coughs or background noise, and critically, it understands medical context. It maps the natural, free-flowing conversation onto structured medical terminology.
And the big win here is the doctor isn't typing during the visit.
Precisely. The doctor can maintain eye contact, focus entirely on the patient, build rapport, actively listen, instead of staring at a screen and trying to type everything accurately while the patient is talking.
That alone feels huge for the patient experience.
It is. And then, after the conversation, the system has automatically extracted the key details, symptoms discussed, diagnoses considered, medications prescribed, follow-up actions needed.
And it generates the notes.
It autonomously generates the clinical documentation, often directly into the standard formats like SOAP notes, subjective objective assessment plan. The draft is usually ready for a quick review and sign off by the doctor almost immediately after the patient leaves the room.
Wow. The impact there seems massive and
Right.
multi-layered. First, you mentioned burnout. Our sources point to administrative burden as a major driver of clinician burnout and staffing shortages.
It's a huge factor. So by taking away hours of mandatory charting time each day, just tedious, repetitive work, you directly combat that burnout. You improve job satisfaction.
And that time saving must have a financial impact, too.
Absolutely. That leads straight to the second major impact: efficiency and the bottom line. The sources consistently show ambient AI for documentation can reduce charting time by huge margins. Figures like 70% reduction are common.
70%.
Think about what that means. If a clinician spends 70% less time on notes, they can potentially see significantly more patients each day, or spend more quality time with each patient. This is how you see studies reporting ROI boosting by as much as 600%. It's a very cost-effective way to handle that high-volume, low-complexity task that previously ate up expensive, high-skill labor time.
It's basically automating the transcription and structuring.
In a highly context-aware way, yes. It understands medical language, abbreviations, the flow of a clinical encounter.
And beyond the scribe function, AMI is also cropping up in remote patient monitoring, right? Using wearables.
Yes, that's another key area. We're talking about wearables, smartwatches, fitness trackers, dedicated medical devices, continuously tracking vital signs, activity levels, sleep patterns, even ECG readings sometimes.
Like the Apple Watch detecting irregular heart rhythms.
Exactly. But it's more than just recording data. This is predictive ambient intelligence. The AI algorithms running behind the scenes, sometimes on the device itself or in the cloud, are constantly analyzing these data streams,
Looking for anomalies.
looking for subtle deviations, patterns that might indicate a potential health issue before it becomes acute. An irregular heart rhythm, a change in gait that could signal a fall risk in an elderly patient, declining sleep quality. The system flags these risks, sometimes hours or days before the patient might even feel symptoms.
So it's invisible intelligence actively participating in preventative medicine, trying to catch problems early.
That's the goal, shifting from reactive treatment to proactive health management, driven by continuous ambient monitoring.
Okay, let's shift gears from the clinical setting to the broader enterprise. How is ambient AI changing how businesses operate? Logistics and supply chain seem like a prime area for this kind of background optimization.
They really are. Traditionally, logistics managers spend a lot of time reacting to problems, right? A ship gets delayed at port, a key supplier has a factory fire, a sudden tariff change. They scramble to find alternatives after the fact.
Firefighting mode.
Exactly. Invisible AI completely flips that model. The system works in the background, continuously monitoring hundreds, maybe thousands of external factors simultaneously.
Like what kind of factors?
Real-time traffic flow data at key ports and highways, hyper-local weather predictions along shipping routes, news feeds for labor disputes, financial health indicators for critical suppliers, things like payment delays reported by other vendors, or sudden drops in their public stock price if applicable, even geopolitical stability assessments for sourcing regions.
Wow, so it's constantly running this massive global risk simulation.
Pretty much. And crucially, it doesn't just flag risks. It has the agency to act autonomously, based on predefined rules and learned patterns.
So it can act before a human even sees the alert.
That's the idea. For example, the system might detect a high probability of an incoming typhoon hitting a major port, combined with chatter about potential dock worker strikes there, instead of just sending a red alert email.
Which the manager might miss overnight.
Right. The AI agent might automatically initiate the process of sourcing alternative trucking capacity inland, maybe reroute high-value or perishable cargo onto expedited air freight, or even preemptively lock in new shipping contracts on a different route, all before the human logistics manager even logs in the morning and realizes there's a potential problem brewing.
So it's preventative maintenance for the entire supply chain, running invisibly.
That's a great analogy. It's proactive risk mitigation integrated directly into the workflow.
That concept seems like it could carry over powerfully in other areas too. Human resources, for example. The idea of using AMI as an early warning system for employee burnout risk, that one really caught my eye. It sounds potentially helpful, but also sensitive.
It is definitely sensitive, and ethical data governance is absolutely paramount here. You cannot do this without transparency and strict controls. But assuming those are in place, the potential is massive.
How would it work? What data would it even look at?
The systems focus on objective, observable metrics, things that are generally available within the enterprise systems already, but rarely analyzed collectively for this purpose. Things like calendar density, how back-to-back are someone's meetings, email patterns, are they consistently sending emails late at night or very early in the morning, badge swipe data, are they coming in less frequently or staying much later than usual, or even anonymized aggregated data on sick day frequency within teams.
And the AI finds correlations, like the source example connecting high calendar density to sick days.
Right. Our sources mention a beta test where they found that calendar density consistently hitting over 85% packed for 3 weeks straight correlated strongly with a subsequent measurable increase in sick day usage, and even project delays or failures within those teams. The AI can spot these patterns across large groups much faster than a human manager could.
That connection between sort of hard system data and these soft human risks is fascinating. But what does the system do? It doesn't just flag someone as at risk, does it?
No, the action needs to be ambient and supportive. It's not about surveillance, it's about proactive intervention. Instead of just raising a flag, the system might, for example, automatically and discreetly suggest to the manager that maybe delaying the assignment of a complex new project to that individual might be wise.
Influencing workload balancing.
Exactly. Or it could subtly surface links to company wellness programs or resources directly to the employee via the intranet portal, framed as a general reminder. It's about adaptive workload balancing and support happening in the background, informed by data points that are too numerous for managers to track manually across a whole organization.
Yeah. And one more in enterprise area, compliance and risk. This often involves incredibly tedious manual checking. Seems ripe for invisible AI.
Absolutely. Compliance is often about pattern matching and adherence to rules perfect for AI. An ambient compliance system can constantly scan communications like emails or chat logs, subject to policy and consent, financial transactions, system access logs, looking for potential policy violations or risk exposures.
Like what? Insider trading flags, data leakage risks?
All of the above. Or even simpler things like ensuring proper documentation is attached to certain transaction types. And again, the key is agency. The system can often autonomously remediate minor issues itself, maybe automatically fixing incorrect access permissions on a shared document or prompting a user to update outdated compliance training records.
And it logs everything.
Critically, yes. It creates comprehensive, tamper-proof, traceable audit trails completely invisibly as part of its normal operation. So when the auditors, internal or external, come calling, the compliance record for the past year isn't something that needs to be painstakingly assembled. It's already there, generated automatically. It could dramatically reduce the time and cost of audits.
We're also seeing MI shaping our physical environments, right? Public infrastructure, private buildings, creating these smart environments.
Definitely. Smart cities are a major application area.
Right.
We see NMI being used to optimize urban life in tangible ways.
Like traffic management.
Yeah, the adaptive traffic signals in places like Singapore and LA are a good example. They're not just on timers. They use cameras with computer vision and predictive modeling based on real-time traffic flow to adjust the signal timings minute by minute, trying to ease congestion dynamically.
And public safety.
AI-powered surveillance is becoming more common, analyzing camera feeds for anomalies. And systems like ShotSpotter use networks of acoustic sensors to detect gunshots, pinpoint the location with surprising accuracy, and alert police immediately. That's deployed in cities like New York and London.
Even basic city services.
Even waste management. Companies like Inevo put sensors in public waste bins. The bins literally tell the collection service when they're getting full. This allows the city to optimize collection routes dynamically, only visiting bins that need emptying, which saves fuel, time, and reduces truck traffic. It's simple, invisible optimization.
And in our workplaces, too, beyond just HR systems.
Smart workplaces are a big focus. Systems that automate meeting room scheduling based on attendees' known locations and calendars. Systems that automatically transcribe meetings happening in equipped rooms. Even HVAC and lighting that adjust automatically based not just on time, but on real-time occupancy detected by sensors. And maybe even collaboration patterns, dimming lights in unused areas, adjusting temperature in busy zones. Companies like Crestron offer these solutions, and Microsoft is building out its campus using digital twin tech, which heavily relies on AMI.
And there's retail. We have to talk about the Amazon Go stores. That feels like the epitome of invisible tech creating a seamless experience.
It really is a prime example that just walkout technology is fascinating because it's more than just cameras watching you.
Right, it's not just computer vision.
No, it relies heavily on sensor fusion. It's combining input from multiple sensor types. High-resolution cameras overhead, yes, but also sophisticated weight sensors built directly into the shelves. They know exactly when an item is picked up or put back. There might even be acoustic data analysis happening.
All working together to build a model of who took what.
Exactly. It builds this complex multimodal understanding of each shopper's identity, usually linked to their app when they enter, and their interactions with products. This allows the system to accurately track items, even if the store is crowded, even if someone picks something up and then puts it back on a different shelf. The goal is utterly frictionless checkout because the tracking is continuous and invisible.
And we see a simpler form of this in online retail too, right? Recommendation engines.
Absolutely. Those AI-driven recommendation engines, like Amazon's famous one, are a form of ambient personalization. They work in the background, analyzing your browsing history, purchase history, what other similar users bought to tailor the product shown to you. Amazon attributes something like 35% of its total sales to that recommendation engine. It's invisible AI shaping your shopping experience constantly.
Okay, we've really laid out the what, the tech, and the how, the applications. Now let's talk bottom line. Let's talk strategy. What are the real, quantifiable, strategic advantages of making technology disappear like this? Why is invisibility the future strategically and not just, a clever user experience trick?
I think the single most impactful benefit, the one that underpins many others, is that radical reduction of cognitive load we keep coming back to.
Freeing up mental energy.
Precisely. By outsourcing routine decisions, monitoring tasks, minor adjustments, by letting the environment handle those, AMI allows users, whether they're doctors, logistics managers, or just consumers at home, to achieve a state of flow.
Flow, like being in the zone.
Exactly. They can focus their precious mental energy on the things humans do best. Strategic thinking, creative problem solving, complex collaboration, empathy. Maximizing the value of human time instead of spending that energy on digital busy work or constantly managing their tools.
Okay, reducing cognitive load makes sense qualitatively, but how does that seamlessness translate into things businesses really track, like ROI or customer lifetime value?
It translates directly through a significantly improved user experience, or UX. When interactions feel effortless, intuitive, almost magical, when the system just seems to anticipate your needs instead of waiting for commands. Users build a real reliance on that experience. It feels better.
And better experiences lead to loyalty.
Absolutely. That reliance translates directly into stickiness. Users don't want to go back to clunky or high-friction systems. This boosts customer retention rates, reduces churn, and significantly increases the overall customer lifetime value. People are often willing to pay a premium or choose one service over another simply because it works better and demands less attention.
And going back to that core operational difference we discussed, speed, that must be a massive quantifiable advantage compared to AI that needs a command first.
It often is, yes. AMI can be orders of magnitude faster in many scenarios, precisely because it doesn't require the human initiation step, the prompt, the click, the voice command. It acts immediately based on context, responding to environmental changes or predicted needs in milliseconds or seconds.
So operations just run faster, more smoothly.
Exactly. Operations become faster, more reliable, more resilient. For that supply chain manager we talked about, that speed is the difference between preventing a costly disruption entirely versus mitigating the damage after it's already happened. That's a huge financial difference.
So putting this together, it sounds like Offering ambient AI capabilities today might be a really strong value proposition, a real competitive edge. But the sources seem to suggest this advantage might be temporary, that it's becoming the new baseline.
I think that's exactly right. We're definitely seeing a market pivot. That Gartner prediction is telling. By 2030, they expect ambient AI to be a core component in 70% of enterprise digital workplace strategies.
70%. That's most companies.
It implies that within the next few years, if your enterprise systems still require constant manual prompting for every routine task, for every bit of information, you'll likely be operating at a significant strategic disadvantage. Seamless, invisible integration won't be a nice-to-have feature. It'll be a fundamental necessity for employee efficiency, operational resilience, and customer satisfaction. It's becoming table stakes.
Okay, that makes sense strategically. Now let's shift our focus a bit. Let's think about the people actually building these systems, the product managers, the engineers, the designers, implementing something that is specifically meant to be pervasive, potentially invisible. That must require a really unique approach, right? Very different from designing, say, a flashy interactive mobile app.
It absolutely requires a different mindset and a distinct implementation strategy. You have to prioritize transparency in the design process precisely because the system aims for invisibility in action. It's a bit of a paradox.
So where do you start if you're a product manager thinking about adding AMI features?
The process really has to start by deeply understanding friction, not just automating an existing process as is, but identifying and automating the repetitive decisions or the annoying micro-interactions within that process. Where is the cognitive load highest? Where do users get bogged down?
Find the pain points that can be smoothed over invisibly.
Exactly. The sources laid out a kind of 9-point framework for this, which seems useful. Starts with purpose. Clearly identify where MII adds real tangible value by removing that friction. Is it automating common customer service queries? Is it streamlining high-volume data entry approvals? Is it optimizing energy usage?
Okay, step one, find the value, remove the friction. Then what?
Then you clearly define what success looks like, what metric will improve. Then you build out that thoughtful technology stack. We discuss the right mix of IoT, edge, cloud, tailored to the specific problem.
And then comes that critical design challenge, the interface, or maybe the lack of interface. How do you design something that doesn't get in the way?
This is key. You design interfaces that are ideally optional or context-driven,
Optional.
meaning the system primarily relies on triggers other than a graphical user interface. Voice commands are one step away from GUI, but still active. Gesture control is another. But true ambient systems often rely on context-based triggers.
Like the meeting room example.
Exactly. The system recognizes you've walked into meeting room 3, sees on your calendar you have a scheduled project update, and automatically starts the room's conferencing system, loads the relevant presentation, slides onto the screen, and maybe even starts a transcript, all without you saying or touching anything.
So the interface is just the environment reacting appropriately.
Right. And that requires the system to be intensely context-aware, constantly adapting its behavior based on time, location, user habits, environmental sensors, linked data like calendars.
It sounds incredibly complex to test.
It is, which is why rigorous testing and iteration are crucial. Beta tests with real users, minimum viable products, MVPs, focusing on one ambient feature first, gathering constant feedback. It's essential because predicting all contextual nuances is impossible upfront.
And woven through all of this is the privacy and security piece. If these systems are constantly gathering behavioral and environmental data, that has to be addressed from day one.
Oh, absolutely. It
Yep.
cannot be an afterthought. It has to be a foundational design principle baked in from the start.
Because ambient implies ever-present, which implies ever-collecting.
Right, so builders have a huge responsibility. You must encrypt communications end-to-end. You need robust data anonymization techniques wherever possible. You absolutely have to ensure compliance with major privacy regulations like GDPR in Europe or CCPA in California. This isn't just legal necessity, it's fundamental to building user trust.
And how do you build that trust for something invisible?
You start small. Pick 1 or 2 high-value, low-risk ambient features first. Prove their value, demonstrate reliability, give users clear controls and transparency about what data is used, even if they don't need to use those controls daily. Build confidence gradually, then scale smartly, always optimizing based on performance and user feedback.
Okay. Now, shifting to a more advanced technical challenge. These ambient systems aren't just adjusting thermostats. They're being designed to manage massive, complex, often critical infrastructure, smart grids, citywide traffic networks, fleets of autonomous vehicles. These systems often have inherent asymmetries, right? Not all players are equal.
That's a really important point, and it leads to some fascinating research challenges, like the work done by engineers at FAU that was mentioned in the sources. They tackled a fundamental problem with how traditional AI control systems often work.
What was the problem?
Many standard AI frameworks, especially in reinforcement learning, tend to assume that all the decision makers or agents in a system are more or less equal and make decisions simultaneously. But that's just not realistic for a lot of critical infrastructure.
Like your smart grid example. The utility company running the grid isn't equal to me deciding when to charge my electric car.
Exactly. There's a clear power hierarchy. The utility company is the leader. They set the constraints, first maybe dynamic electricity pricing based on overall demand, or limits on total power draw in a neighborhood. Then, the followers, individual households, smart appliances, EV charging stations, have to optimize their behavior within those constraints set by the leader. They react.
It's not a simultaneous negotiation, it's a sequential game.
Precisely. It's an asymmetric hierarchical structure. And trying to model that using standard AI that assumes symmetry leads to inefficient or even unstable outcomes.
So the FAU engineers needed a different approach, something that could model this leader-follower dynamic using game theory.
That's what they did. They developed a smarter AI control framework specifically structured using the Stackelberg-Nash game model.
Stackelberg-Nash, okay, that's a game theory concept.
Yes, it's a model specifically designed for sequential games with a designated leader and followers. Their reinforcement learning framework explicitly assigns roles. A leader agent, like the central grid controller, makes its strategic move first. And then the follower agents, like individual smart homes or vehicles, calculate their best response based on the leader's move. It accurately reflects the real-world power dynamic.
So it finds a more realistic, stable equilibrium for the whole system.
Right. It finds the optimal strategy considering the hierarchy. But they added another crucial layer of intelligence on top of that.
What was that?
They realized that in these massive systems, having every single follower agent constantly recalculating and communicating its optimal strategy back to the leader at every single tiny time step, well, that would be incredibly inefficient.
Yeah, the communication overhead, the processing load, it'd be huge, right? Especially with potentially millions of devices.
Unsustainable. So they added an event-triggered mechanism to the control loop.
Event-triggered, meaning it only updates when something actually changes significantly.
Exactly. Instead of updating decisions on a fixed clock cycle, every second, every minute, the system only triggers an update or recalculation when necessary. For example, if there's a sudden, unpredicted surge in energy demand, or if the leader, the grid operator, issues a significant change in pricing constraints, or if a follower device's local conditions change dramatically.
So if things are stable and within expected parameters, everyone just keeps doing what they're doing based on the last optimal plan.
Correct. This only update when needed approach dramatically saves energy consumption, network bandwidth, and processing power across the entire system. It makes managing these huge, complex networks feasible while still maintaining overall stability and ensuring everyone operates efficiently according to the leader's strategy. It's a very clever piece of engineering for large-scale MI control.
That deep focus on managing complexity and enabling autonomous control naturally brings us right back to that necessary friction we mentioned earlier. The really thorny issues, the challenges, the risks, the ethical questions that inevitably arise when technology operates silently, continuously gathers data, and starts making proactive decisions for us. So, when the tech successfully disappears, what are the biggest risks that emerge? What keeps people up at night when thinking about trust and security in an ambient world?
I think the number one challenge, the one that underpins many others, is trust and transparency.
Because you can't see it working.
Precisely. Since the decisions often happen autonomously, in the background, below the threshold of our normal awareness, users might have no idea how or why a particular action was taken.
Like the doctor wondering about the AI scribe summary, or the logistics manager questioning that unprompted rerouting.
Exactly. Why did the smart thermostat turn down the heat? Why did my autonomous car choose that route? Why was my loan application flagged by the ambient risks system? This inherent lack of visibility into the decision-making process can lead to significant trust issues, especially when the stakes are high, like in finance or healthcare or critical infrastructure.
We're seeing efforts in the broader AI world around explainable AI, or XAI, to try and address this black box problem. How do you even apply explainability to a system that's fundamentally designed not to be interacted with?
That's a fantastic question, and it's a critical design requirement for responsible AMI.
Mm.
You obviously can't have the system constantly interrupting the user's flow by flashing up a complex decision tree or a list of feature importances every time it adjusts the lights. That defeats the purpose.
Right.
So XAI for ambient intelligence has to be different. It needs to focus on providing an easily accessible, understandable rationale on demand or after the fact. The system needs robust logging capabilities recording the key data points and the logic path that led to a significant autonomous decision.
So you can investigate later if
Well,
needed.
exactly. The user or an auditor needs the ability to pull up a clear, maybe simplified explanation. The heating was adjusted because occupancy sensors detected no one in the zone for 30 minutes, and the external temperature was above the threshold. It's about providing auditability and transparency without destroying the seamlessness of the core experience.
Okay, so trust through optional post-hoc explanation. What's the next big challenge?
It has to be privacy and data usage. We've touched on it, but it's huge. The very nature of AI ever present and ever collecting is its power, but also its peril.
It needs all that data for context, but
But it means these systems are potentially vacuuming up vast amounts of behavioral data, environmental data, location data, potentially even biometric or health data conversations continuously.
which sounds like a recipe for mass surveillance if not handled carefully.
It absolutely represents that potential. And we've already seen significant public and regulatory pushback against technologies perceived as enabling this. Think about the bans or restrictions on facial recognition technology implemented in cities like San Francisco back in 2019. Those came directly from citizen concerns about uncontrolled surveillance.
So balancing the convenience of AMI with fundamental privacy rights is crucial.
It's the tightrope walk. Corporations building these systems have an enormous ethical responsibility, and increasingly a strict legal obligation under laws like GDPR and CCPA. They must have transparent policies detailing exactly what data is collected, why it's needed, how it's used, how long it's stored, and who can access it. And critically, users need granular control and meaningful consent options. It can't be an all-or-nothing proposition.
Okay, trust and privacy. What about security? More connected devices surely means more ways for things to go wrong.
Definitely. The security risk increases exponentially with AMI. Why? Because you're moving from securing a few main endpoints, like a laptop or a server, to securing potentially hundreds or thousands of tiny distributed IoT sensors and edge devices.
Each one is a potential doorway for hackers.
Each one creates a potential entry point, yes.
Yeah.
It massively expands the overall attack surface, and many of these devices are low cost, maybe not built with security as the top priority.
And we've seen real-world examples of this going badly.
Sadly, yes. The source material mentioned the 2020 cyber attack on that smart building in Finland. Hackers found vulnerabilities in the building's automation system, the invisible ambient controls for climate. They exploited them to completely disable the heating and hot water systems during a harsh Finnish winter. That's not just inconvenient, it's dangerous.
Wow. So securing AMI isn't just about the cloud, it's about the entire chain.
Absolutely. It requires end-to-end encryption, yes, but also robust security practices throughout the supply chain, ensuring the chips and components being embedded in these devices aren't already compromised. It's a complex security challenge.
Okay, one more challenge that seems important is the human element itself.
Yeah.
The risk of just getting too used to it working perfectly.
That's the risk of over-reliance and the loss of human oversight. If the AI smoothly handles 99.9% of routine complexity, making everything feel effortless, do we become dangerously dependent?
What happens in that 0.1% when the automation fails unexpectedly?
Or when the system encounters a truly bizarre, unforeseen situation, an edge case, that it simply wasn't trained on and doesn't know how to handle? The human user, who hasn't had to actively manage the system or make those kinds of decisions regularly, might be slow to notice the failure, or might have lost the skill or confidence to intervene effectively and take back control.
Like pilots needing to maintain manual flying skills, even with advanced autopilots.
It's a very similar principle. We need to be deliberate in designing these systems. There must be clear human-in-the-loop fallback models, mechanisms that automatically engage human judgment or require human confirmation whenever the AI's internal confidence score about a situation drops below a certain threshold, or when a decision involves crossing critical safety or ethical boundaries. We can't design humans completely out of the loop, especially in high-stakes domains.
So if the whole point is invisibility and seamlessness, how do you actually design for responsibility in this inherently risky environment?
It comes down to designing for governance from the outset. This means corporations need to proactively establish clear guardrails, ethical guidelines, and formal governance frameworks before deploying these systems widely.
Like AI ethics boards.
That could be part of it. Having dedicated bodies to review the potential impacts, monitor for bias, ensure fairness, and oversee the accountability structures for these autonomous systems. It also means embedding those human-in-the-loop models we just discussed, having documented, tested procedures for when and how human judgment is re-engaged. It's about building safety and accountability into the invisible architecture itself.
Okay, despite those very real, very significant hurdles, trust, privacy, security, over-reliance, the path of innovation seems pretty clear. We kicked off this discussion talking about how we started in an era of prompt engineering interacting directly with AI. But the future seems to be heading somewhere quite different and much less visible.
I think that's right. The trajectory seems to be moving away from just refining how we command AI towards designing systems where the primary interaction model is more like behavioral nudging of autonomous agents.
Nudging agents, what does that mean in practice?
It means we're moving towards creating intelligent infrastructure, where AI systems and humans coexist more fluidly. The AI isn't waiting for a specific command, but it's constantly sensing, predicting, and gently optimizing the environment or the workflow based on anticipated human behavior and goals. It's less direct control, more background orchestration.
And a key outcome of this is achieving really deep personalization, right? What the sources call hyper-personalization at scale.
Exactly. This goes way beyond just remembering your preferred temperature setting. Ambient AI systems will increasingly adapt the entire user experience based on individual identity, real-time context, past behavior, and maybe even inferred emotional state.
Like the smart office example.
Right. Imagine an office that uses secure biometric recognition, like facial or voice patterns, as you walk in. It doesn't just unlock the door. It instantly adjusts the lighting at your specific workstation to your preferred brightness and color temperature, sets the desk height if it's adjustable, maybe even queues up your relevant project dashboards on the near screen, all based on your securely stored personal profile. Cisco's Smart Workspaces concept points in this direction.
So the environment molds itself to the individual instantly and invisibly.
That's the goal. And the really ambitious long-term vision, which you see in research projects like Samsung's Neon AI avatars, is for AI assistants or ambient systems to develop a kind of emotional intelligence, to be able to subtly infer user mood or stress levels from tone of voice, language patterns, maybe even physiological signals from wearables,
And adapt accordingly.
and adapt their responses, their suggestions, or the environmental settings accordingly, providing information more gently if stress is detected, perhaps proactively suggesting a break. It's about adding a soft, invisible layer of potentially empathetic computing.
That's fascinating. I'm also really interested in how this connects to broader societal goals, like sustainability. Sustainable smart spaces seem like a perfect application for this kind of continuous background optimization.
Oh, absolutely. It's a massive opportunity and likely a major driver for adoption. Future smart homes, smart offices, smart cities, they will almost certainly have sustainability and energy efficiency as core design principles. And AMI is the key enabling technology for achieving that.
By constantly fine-tuning energy usage.
Exactly. By using sensors and AI to optimize everything in real time based on actual need, not just static schedules. The famous example is the Edge building in Amsterdam.
Often called the world's smartest, greenest office building.
Right. It uses something like 28,000 sensors, tracking light levels, temperature, CO2, occupancy in every single corner, even how often the coffee machines are used. This incredibly granular real-time data feeds into an AI platform that continuously optimizes heating, cooling, lighting, ventilation, everything.
And the results are significant.
Hugely significant. The sources say it's something like 80% more energy efficient than comparable traditional office buildings. That level of optimization is only possible through constant, invisible, data-driven adjustments made by the ambient intelligence system.
And we see this on a city scale, too.
Yes, like the smart streetlights example from Barcelona. They're equipped with motion sensors. If no pedestrians or vehicles are detected nearby for a certain period, the lights automatically dim down to a lower level. Multiply that across thousands of streetlights, and you get very significant, measurable reductions in electricity consumption and maintenance costs for the city. Again, it's invisible intelligence making infrastructure greener and more economical.
Okay, so hyper-personalization, sustainability. Let's look one last time at that furthest horizon, advanced human-machine interaction, HMI. We mentioned voice and gesture control, like ultra-leap systems for touchless interfaces. But where does it go next?
Well, beyond refining voice, gesture, and context awareness. The truly long-term, perhaps paradigm-shifting vision comes back to brain-computer interfaces, BCI.
Back to Neuralink and similar efforts.
Right. While still largely in research and early therapeutic applications, the ultimate goal for some in the MAV field is to allow seamless control of smart systems and ambient environments purely through thought or intention, decoded directly from brain signals.
That would be the ultimate invisible interface. No speaking, no gesturing, just thinking.
It represents the deepest possible integration of invisible AI into the human experience. The system wouldn't just react to your behavior. It could potentially anticipate and respond to your cognitive state, your intentions, perhaps even before you're fully consciously aware of having decided something. That's the far future vision.
Wow. Okay, this has been a really comprehensive deep dive. We've covered a lot of ground. I think the big takeaway for me is that the next phase of this AI revolution, it isn't solely defined by the chatbots and the large language models that we actively interact with. It's perhaps more profoundly defined by this architectural shift, moving from AI as a distinct tool we command to AI becoming invisible infrastructure that's woven into our environment, constantly sensing, acting, and anticipating our needs, often without us even noticing.
I think that's exactly right. And the true measure of success for ambient invisible intelligence, perhaps counterintuitively, is exactly that. You don't notice it working. When it's truly successful, it just fades into the background.
So the real innovation isn't necessarily in making AI louder or more obviously intelligent in its interaction with us.
No, I think the deeper innovation lies in making it genuinely helpful, making it fundamentally human-centered, and making the interaction effortless, almost subconscious. It's about creating environments and systems that feel like they just run themselves, perfectly adapting to support whatever we're trying to achieve.
Which leaves us, and you listening, with a final, maybe somewhat provocative thought to chew on as we navigate this rapidly evolving landscape. If the most powerful, the most transformative AI systems are increasingly designed to operate seamlessly and invisibly in the background, continuously optimizing our workplaces, our homes, our cities, preempting problems before we're even aware of them, how will we, as citizens, as employees, as consumers, learn to effectively audit these systems? How do we question them? And ultimately, how do we build and maintain trust in systems whose massive, ongoing operational impact we are, by design, no longer intended to see?
That question of trust in the invisible, that might be the biggest challenge of all.